Hello and welcome back to Dr. Logic Awkwardly Does Logic. I promised you information about how many distinct modalities there are in S4, because what we've seen from the four modal reduction principles that we have is that anytime that we've got two modalities in a row, we can reduce them down to one, and anytime that we have alternating pairs of modalities, we can always reduce them down to just one pair of those modalities. So I'm going to pull up our whiteboard just so I can sort of give you an example of how these reduction principles work. So for instance, if we have the modality box, diamond, box, box, diamond, box, diamond, box, diamond, diamond, and then the caveat. Doesn't matter what the proposition is. We're just interested in the string of symbols. In system T, this is irreducible. You can't have any further analysis of what is going on in this other than simply working through the truth conditions and looking at what is true in every world that is true in some world that is true in some world, et cetera, et cetera, et cetera. In S4, because we have the modal reduction principles, we can slowly make this, we can reduce it at every stage into something simpler and a little bit more intuitive. So there's a variety of ways we can do it, but honestly, the most straightforward is to just go and wherever you find a pair of something. So look, ooh, I've got two boxes. I'm going to reduce this down into just one. Remember, because the reduction principles are equivalences, we can do substitution of equivalences anywhere in the formula. So I don't have to start at the right-hand side. I don't have to start at the left-hand side. I can simply do it anywhere that I want. So here I've got a pair of diamonds. I'm going to reduce that down into one diamond. And so then I've got box diamond, box diamond, box diamond, box diamond, P. So now I don't have any strings of the same pair of operators, but I do have a bunch of pairs of alternating pairs. So we've got 1 and 2 and 1 and 2. So the modal reduction principle that says if you have box diamond, you can reduce it down to box diamond gets us this over here. And exactly the same thing here. Box diamond becomes just box diamond. And then look, I have yet again one more pair of these, so I can reduce them down to this. So this long formula up here is equivalent to just necessarily possibly P. This is great because it means that we can take arbitrary long, arbitrary complex strings of modalities and reduce them down to much more simple ones. Now, this case didn't involve any negations, but you could figure out how to do it with the negations. You just add in modal interchange and double negation if you need to. At this point, the question that you should be asking is, can I reduce this any further, or is this as far as it goes? Or rather, the more broad question is, how many irreducible modalities are there in S4? Now, what I'm going to do, just because the proof is going to get complicated, is I'm going to give you the statement of the result in this video, and then make you wait for the proof for the next video. On the other hand, if you just need the result of the statement, you can get it here. And if you don't care about the details of the proof, lucky you. I do recommend that you watch through the proof video at least once, because it's a really interesting technique. But for now, this is what we are going to prove, this theorem, that there are 14 distinct modalities in S4. So these cannot be reduced to anything other than themselves. So these 14 are the null case, i.e. the case where there is no modality, no box, no diamond, no negation. It's really hard to represent it, so I'm just going to do this little underline. That's the first one. And then we have, yeah, let's write that nicer. We've got the second one is the box. The third one is the diamond. I think my mouse just doesn't like it when I make dots. The fourth one is box diamond. The fifth is diamond box. The sixth is box diamond box. And the seventh is, I'll write it down here, diamond box diamond. Now you might be saying, wait a minute, that's only 7. You said there were 14. It's because it's all of these and their negations. So instead of having the null case, we just have negation, but then we have box not, diamond not, box diamond not, diamond box not, box diamond box not, and diamond box diamond not. So there's 7 positive or affirmative modalities and 7 negative. When we come to proving that these are the only distinct modalities in S4, we will only prove the positive case. The negative case, you basically get for free by going back through the proof and writing down everything that you just did with some negations in place. So there's the result. I'll give you the proof in the next video. Hang on, be patient. I'll get to it soon. Until then, take care and see you later.